Hi everyone.
Welcome to amazing channel of Brilliant Katha.
When you are rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
Halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant.
Hello students, good evening. Welcome to day 14 of our 16 days MCQ challenge. Today we are going to discuss, first session will be physics, second session will be chemistry. We are going to discuss the chapters with maximum weightage, that is optics, ray optics and wave optics together. So we are going to discuss most probable questions and I'll try to complete as many questions as possible in this 1 hour. So I'm expecting your quick comments and response. Take a paper along with me. You should also have to do the numerical, practice this and comment quickly. So without wasting time, let's go. So these are the two chapters we are going to discuss today, ray optics and optical instruments, and then wave optics. Question number 1. A convex lens of focal length 40 cm is in contact with a concave lens of focal length 25 cm. The power of the combination is. By seeing this question itself, you got an idea. It is based on combination of lenses. In combination of lenses, my dear students, we have formulas to find the effective focal length and effective power. What is the formula for effective focal length? 1 by f is equal to 1 by f1 plus 1 by f2 plus etc. Where f1 and f2 are the focal length of the two lenses. And power, combination of power formula is, you know that it's P is equal to P1 plus P2. If P1 is the power of the first lens and P2 is the power of the second lens, then the total power can be calculated by simply adding the powers. So let's check. First one is convex lens of focal length 40. Second one is a concave lens of focal length 25. My dear students, please be careful about the sign convention. You know that for a convex lens, the power is, the focal length is positive, and for a concave lens, it is negative. So they are asking, what is the power of the combination? So we need to find P1 and P2. Let's quickly find P1 and P2. What will be P1? P1 will be 1 by F1. What is F1? It is 40. Remember, 40 centimeter. You know the unit of power, SI unit of power is diopter. It is meter inverse, so we need to convert centimeter into meter. So let's check. 1 by F1, 40 centimeters. So 40 into 10 power minus 2. So it will go up. We get 10 power 2, which is 100. So it will be 100. So we get 10 by 4, that is 2.5. 2.5 diopter is the power of the first lens. And what about P2? P2 will be 1 by F2. What is focal length of the second one? It's 25 centimeters. So it is 1 by 25 into 10 power minus 2. It will also go up. It is 100 by 25. It's 4. And again, please note that it's a concave lens. What is the sign of power of a concave lens? Is negative. So this is -4 and this is plus 2.5. What is the combination focal length? Just add them. 2.5 plus -4. The answer is -1.5 diopter. Check the option. Yes, it's option A. Option A is our right answer. -1.5 diopter. So combination of lenses is an important topic, easy topic. Please be careful about the sign convention. You know that a very silly mistake will lead to a wrong answer. So I'm expecting the comments. Yes, Atul, Fasil, Mohammad Hisham, very good dear students. All your comments, all your answers are correct. So I'm going to the second question. Second question is, A prism has a refracting angle of 60 degree. When a ray of light is incident on its face at 45 degree, it suffers minimum deviation. Then the angle of minimum deviation is prism. You know the importance of that topic. It's a probable 5-mark question. It's a topic from they can ask many numericals, and in that we have final equation. Hope you remember what is the final formula. It is for the refractive index of the material of the prism. What is the formula for that? N is equal to sin A plus D by 2 by sin A by 2. But here that's not the question. Please be careful what they are asking. Prism has an angle of 60 degree. Angle of the prism is 60. Ray of light is incident on its face at 45 degree. So angle of incidence is given as what? 45 degree. I is equal to 45 degree. At that angle it suffers minimum deviation. Then what is the minimum deviation position? Hope you remember in between that, in that long derivation I told you, like in the class, we have to focus on sum or equation. One is D is equal to I plus E minus A. Small d is equal to I plus E minus A. Yes, you can comment your answers. Right. So at minimum deviation, capital D, if you are writing, it will be I is equal to E. We get 2I minus A. So directly we can substitute 2 into what is the angle of incidence? 45. 2 into 45 minus angle of the prism is 60. 90 minus 60. The answer is 30 degree. How many of you got the correct answer? Yes. Sanj, Ruben, very good, right answer. So it is option A, 30 degree. So prism, once again I am saying students, very important topic. 5-mark question they can ask. Different type of numericals are there. Question number 3. Look at this. A plane or convex lens has a radius of curvature of 30 centimeter. If the refractive index is 4/3, then the focal length is which formula? The most important topic from ray optics chapter. What is it? It is lens maker's formula. So this is a question based on lens maker's formula. You can start doing along with me. It is what type of lens? It's a plane or convex. You know what is a plane or convex lens? Plane or convex means one side is flat and other side is convex. So we can draw a plane or convex lens like this. And it is given, its radius of curvature is what? 30 centimeters. So R is equal to 30 centimeter. Refractive index is 4/3, the focal length of the lenses. So I told you, like, this is based on, if this type of question comes, no doubt directly go with lens maker's formula. Tell me what is lens maker's formula? Lens maker's formula is 1/f is equal to n2/n1. But here n1 is air, so n2 is enough. So we can write it as n minus 1 into 1/r1 minus 1/r2. 1/r1 minus 1/r2. This is lens maker's formula. You can comment your answers. I can see that G, I don't know the name of that student. Anyway, G. It'll be good if you can mention your name, G, like you are saying that it's option B. Let me check. Okay, so 1/f is equal to n. What is refractive index? It's given as 4/3. So 4/3 minus 1 into 1/r1. What is R1? Every lens has two refracting surfaces. You know that. This lens also have two refracting surfaces, but the thing is, the first surface is a flat surface. So R1 is the radius of curvature of the first surface. R2 is the radius of curvature of the second surface. So for a flat surface, what is the radius? Flat surface means you know that the radius is infinity. We have discussed this type of questions already. So we can put R1 as infinity. So we get 1/infinity minus 1/R2. What is R2? R2 is 30. Second surface. But again, please note the sign. Is it positive or negative? You know that for a spherical refracting surface, if incident ray are going like this is the first surface, this R is positive, and the surface is like this, means that is negative. That means the sign of the second surface is negative. So we get 1/infinity minus 1/30. So you get like this. So this will become 4 minus 3, 1/3 into 1/infinity 0, but this is positive by what? 30. So 1/f is equal to 1/90. That means f is equal to what? 90 centimeter. So 90 centimeter is the right answer, option B. How many of you got this answer? Yes, Chris, very good. Ruben, Hisham, Karthik, Atul, very good, dear students. Keep going. So I'm going to the next question. Next question, question number 4. Look at this. A glass prism of mu equal to 1.5 is immersed in water as shown. A beam of light incident normally on the face AB. I hope you can see which face is AB. The top face is AB. Is internally reflected from the face AD. So this is AD, internally reflected from the face AD, so as to incident normally on face BD. Given that the refractive index of glass is 3/2 and that of water is 4/3, then the value of theta is such that. A bit confusing question, but if you're doing it carefully, if you're approaching it carefully, this one also you can do. Like, let's try to understand the situation clearly. Refractive index of the prism is 1.5. It's given, it's 1.5. A beam of light incident normally on the face AB. So where is the incident ray? We can draw the incident ray like this. It is falling normally. Normally means, you know, that it will go like straight only. It will go like this. Okay, so it will be going straight. And after that, what is happening? AB is internally reflected from the face AD. So this is the face AD. So from the face AD, it is internally reflected. That means after that, from this point, it is coming in this way. This way. Got it? Yeah, this way. This is what happening, and normally to passing normally or incident normally to the face BD. So this is the face BD. It is going like that. So this is the path of the ray. The ray is going like this. Given that the refractive index is, so value of theta only they're asking. So you can understand this is based on which topic? Surely it is based on what? Total internal reflection. So total internal reflection means, hope you remember the condition, the formulas. What are the conditions for TIR? Condition number 1 is the ray must travel from denser medium to rarer medium. Number 2, the angle of incidence must be greater than the critical angle. So here, first let us check what is the angle of incidence. Angle of incidence for the second phase. Look students, the ray is falling here. That is the point of incidence. So to mark angle of incidence, we have to draw a normal to that point. So if I am drawing a normal to that point, it will be something like this. Normal to the point of incidence. I can draw it like this. So this is a normal. Then which angle is the angle of incidence? Surely you can see this is the angle of incidence, angle between incident ray and normal. The question is, what is the value of that? See, this is theta, this is 90. So surely this will be what? 90 minus theta. This angle will be 90 minus theta. And what is this total angle? Because this is a normal, means this total angle is 90. Total angle is 90. This is 90 minus theta, means this will be what? Theta. So we got an idea that angle of incidence is nothing but theta. I is equal to theta. That is the first point you have to note here. I equal to what? Theta. Okay, right. Now tell me, what is the condition for TIR? For TIR, angle of incidence should be greater than critical angle. That means I should be greater than what? C. So I greater than C means sin I should also be greater than what? Sin C. So here what is I? It is theta. So sin theta, LHS I am writing sin theta should be greater than what? Sin C, sin C. What is the formula for refractive index in terms of critical angle? You know that 1 by sin C is equal to ND by NR. Do you remember this formula? 1 by sin C equal to ND by NR, which means sin C is equal to NR by ND. NR by ND. What is NR? It is refractive index of the rarer medium. Please note that here, which is the rarer medium? Rarer medium is liquid. Okay, because TIR is happening here. So the ray is traveling from glass to water. So glass is denser and water is rarer. So rarer is water. What is the refractive index of that? 4/3. So NR is 4/3 and ND, denser medium, that is prism. Prism is made up of glass. What is the refractive index of glass? 3/2. So this will go up. We get 4/3 into what? 2/3, which is equal to 8/9. This is sin C value. So I'm just substituting that sin C value here, 8/9. Now you can comment your answer. What is the condition for TIR? Sin theta is greater than 8/9. Yes. I can see the answers. Yes, Chris, G, Hisham, Sanj, very good. Veda Dhwani, yes, correct. The answer is option A. Option A. Please Comment others also. I need your active participation. I can understand you people are getting the idea. Satvik, very good. So please note that what's the concept we are using here. It is TIR, the condition for total internal reflection. You have to analyze which is rarer, which is denser. Just recall the formula and substitute. I'm going to the next question, my dear students. Question number 5. Critical angle is maximum when light travels from. Critical angle is maximum when light travels from water to air, glass to air, glass to water, air to water. This question I am leaving to you quickly. In which case the critical angle will be maximum? See, I'll give you the idea. Critical angle maximum means, what is the formula for critical angle? Sin C, 1 by sin C is equal to what? ND by NR. That means sin C is equal to NR by ND. So for C to be maximum means obviously sin C should be maximum. Okay, so you can just check in which case NR by ND is maximum. That is the answer for this. NR by ND is maximum for which case? I can see B from many students. Let's check one by one, my dear students. What is option number 1? Water to air. Water to air. Option A is water to air. So NR by ND only we need to calculate. So here which is water to air means which is denser? Denser is water, air is rarer. So we get rarer is 1 by water is 4 by 3. So we get how much? 3 by 4. 3 by 4 value is 0.75. So that is the first one. Let's check B. One by one we can check. Glass to air. Glass to air, it's 1. What is for glass? 3 by 2. 3 by 2. So we get what? 2 by 3 here. Yes or no? 0.66 like that. Yeah. Now let's check C. Glass to water. Glass to water. Glass to water means which is rarer? Water is rarer. So water is rarer means it is 4 by 3 divided by what? Glass is 3 by 2. So we get 8 by 9. 8 by 9. Now let's check air to water. Air to water, it is not possible. You know that air to water means it is rarer to denser. There is no point of critical angle. Can you tell me which is right answer, my dear students now? Quick. Yes. Chris, right answer. The one which maximum value of this. Others also comment. Is it B? No. It is option C. Option C is the right answer. Yes or no? I hope that is clear. The concept is clear. Out of these three, the biggest one is this one. Yes or no? Please comment. Yeah. Correct. Yeah. Right. So please note that it's actually a very simple question. Just an idea of what is the formula for refractive index in terms of critical angle. So you can just use that concept here. Alright. Okay. Satvik, correct. I'm going to the next question, number 6. Wave optics question. A single slit of width d is placed in the path of a beam of wavelength lambda. The angular width of principal maximum obtained is. Direct question. Recall the formula. Comment your answers, please, my dear students. Angular width of central maxima in diffraction pattern. Angular width of central maxima. See, in wave optics we have like Huygens principle, laws of reflection, refraction, interference, diffraction. You know that. These are the topic from wave optics chapter. And in diffraction there are very few, less number of formulas only. One is for the width of central maxima. What is it? If this is a slit of width A, this is a screen, it is kept at a distance D, and this is the central maxima, width of central maxima. What is the formula for the width of central maxima? We got an equation like width is equal to 2 lambda d by A. This is the formula for the width of the central maxima, isn't it? Yes, but please note that this is which one? It is the linear width of the central maxima. Linear width means what is the length from here to here. But what they are asking? They are asking the angular width. Okay, I can see the comments. Very good. So angular width means this angle. So to get that angle, we should divide it by the distance using the concept like angle is equal to arc length by radius. So angular width theta is equal to linear width by the distance d. So we get what? 2 lambda upon A. A is width of the slit, but in this question it is given the width of the slit as D, so we get what? 2 lambda by small d. Option C is the right answer. C is the right answer. Yes. Yeah, very good. Rida. Correct. Yeah, Karthik, right answer. I'm going to the next question. I hope there is no doubt about this. Simple question. Please note that they may be asking some questions like when the distance between the slit and the screen is doubled, what will happen to the angular width? Such question also they may ask, like, you know that angular width is independent of capital D. If you are keeping at 50 centimeter, 1 meter, 2 meter, linear width will change, but angular width remains the same. Angular width is independent of the distance between slit and screen. Yes. So I'm going to the next. Yeah, very good. Next question, question number 7. In Young's double slit experiment, the separation between the slits is halved and the distance between the slit and the screen is doubled. The fringe width will be. How many times we discussed this question in the class? You can see this question in many papers, previous year paper. What will happen? Please comment your answers quickly. In Young's double slit experiment, the separation between the slits is halved and the distance between the slit and the screen is doubled. What will happen to the fringe width? Will be unchanged, halved, doubled, quadrupled. Yes, I can see Rida, G, Satvik, all are commenting the right answer. Ruben, very good. Yes. Yes. So simple, right? What is beta value? Tell me. Beta formula is equal to lambda capital D by small d. Very, very important equation. Fringe width. Beta is equal to lambda d by small d. So here, what is given? Beta dash. We have to find the new. Lambda, there is no change. Distance between the slit and the screen is doubled. That means d becomes 2d and the distance between the two slits is half, d by 2. So this 2 will go up, we get 4 lambda d by small d. That means 4 times 4 beta. Okay, answer is quadrupled. All of you got the right answer. Very good. Keep it up. Going to the next. Yes. Question number 8. Again, YDSE question, Young's double slit experiment. The distance between the two slits is 0.1 millimeter. And the wavelength of light used is 4 into 10 power minus 7 meter. If the width of the fringe on the screen is 4 millimeter, the distance between the screen and slit is. You can understand this is a direct question. They are directly asking. But my dear students, please don't make calculation mistake. Take your time for these kind of MCQs, because you know, if you're making a very silly mistake, you can see the datas are given in different units. That will also be confusing. Even options are some in meter, millimeter, centimeter. So in different units only options are also given. So please be careful. Take your time and tell me the answer quickly. Yes, I can see the answers. I hope you are commenting the answer for this question only, G, not for the previous one, right? Okay, so just substitute and find it. What is the formula? Again beta, right? Beta is equal to lambda d by d. They are asking what's the value of capital D. So D is equal to beta small d by lambda. Beta small d by lambda. Yes, very good. G. Correct. Now beta value you can substitute. What is beta? If the width of the fringe on the 4 millimeter, so 4 millimeter, 4 into 10 to the power minus 3. What I felt in class is still some students have doubt about how to convert this millimeter into meter, micrometer into meter. Please study these things, okay? You are going to finish your 12th grade, still you don't know how to convert units means. That's not good. So those who have confusion, study now itself how to convert centimeter into meter, millimeter into meter, micrometer, nanometer, Armstrong, because questions can be given, datas can be given in different units. Okay, right. So millimeter is 10 power minus 3. What is D value? Width of the slit, it's 0.1 millimeter. 0.1 into 10 to the power minus 3. And wavelength lambda is 4 into 10 to the power minus 7. Answer is very simple, right? Minus 3 and 0.1 will become minus 7, minus 7 got cancelled, 4 got cancelled. Answer is 1 meter, yes or no? 1 meter, yes. Many of you got the right answer. Rida, Sanj, Hisham, Karthik, very good. So it is option D, 1 meter. Okay? Easy question, direct question. The only mistake that we may make is in converting unit and calculation. So please be careful. Double check your answers. Yeah. Number 9. The angular, see that same question which I discussed, the topic I discussed, the angular fringe width does not depend upon. Angular fringe width does not depend upon wavelength, the distance between the slit and the screen, ratio lambda by d. Yes, it's option C, right? Very good. Distance between, it is independent of the distance between the slit and the screen. Yes or no? Yeah, correct. Going to the next question, question number 10. In optical fibers, the ratio of the refractive indices of core to cladding. Atul, please be careful. Angular width depends on wavelength. It is independent of capital D. I told you already, capital D, the distance between slit and the screen. Okay, yes. What is this? Optical fiber. In optical fiber, what is the ratio of refractive indices of core to the cladding? Core to the cladding. Comment your answers, please. Yes, already I can see the comments. Sanch, correct. Yeah. Simple, right? So what is the structure of an optical fiber cable? Like the covering is called the cladding. The inner part is called what? Core. And you know that it is working principle is total internal reflection. For that the light needs to travel from denser medium to rarer medium. So the path of ray will be like this. That means the core should be what? A denser medium. Core is denser means its refractive index has to be higher. In normal ordinary optical fibers, this is 1.46 and this is 48 and this is 1.46. So what about the ratio? The ratio will be 1.48 divided by 1.46. This number may vary, but to work this optical fiber, the core should have high refractive index. So what we can say about the ratio? The ratio should be greater than 1. Very good, Atul, Satvik. Yeah, the correct answer, it is option C. The ratio of refractive indexes of core to the cladding. Please don't by heart these values because in question they may change like cladding to core also. So read the question carefully before answering. Okay, core to the cladding means it is greater than 1. If they are asking cladding to the core means it will be less than 1. Understood? Yes. So we are going to the next question now, question number 11. Critical angle for a light going from medium X to medium Y is theta. The speed of light in medium X is V. The speed of light in medium Y is. Not a tough question, my dear. Read it carefully. You can answer it. I'm sure you can answer it. All of you can answer this question. Think. Critical angle for light going from medium X to medium Y. The ray is going from medium X to medium Y. The critical angle is theta. Okay, medium X to medium Y means you can understand which is denser. X is denser. X is denser. Okay, so I'm just separating the two media. This is medium X and this is medium Y. The ray is traveling from where? X to Y. Okay, so we have a formula for critical angle. What is it? Critical angle 1 by sine C is equal to ND by NR. This is our formula. Refractive index of denser medium by refractive index of rarer medium. So here which is denser? The ray is traveling from medium X to medium Y. So I can put for ND as N of X and NR as N of Y. Okay. Now they are asking question based on the speed. You know the relation between refractive index and speed. So LHS is 1 by sine C. I'm keeping as it is. And NX, N is equal to C by V. So C by V. V in what? X. The speed of light in medium X is V. Okay. Divided by NY will be C by, that we don't know. Let's take it as V dash. So we have to find V dash value only. And here critical angle is given as theta. So instead of C, I'm writing theta. Okay, now C got cancelled. We get 1 by sine theta is equal to what? V dash by V. We got the answer. They are asking what is V dash? Tell me. V dash is equal to what? V dash is equal to. Yes. Comment your answers, please. V dash is equal to V by sin theta. V by sin theta. Yes, Atul. Others also. I hope it is clear. If any doubt, you can ask me. Yes, Sanj, correct. Yeah. So it is V by sin theta. V by sin theta. Is it a tough question? No, right? It's not a tough one. Just use the idea. All questions are conceptual only. Okay. Yes. Fine. Rida, I think you made a mistake. Or was it the answer for the previous question? I don't know. I can see option C. Okay, anyway, you check. Yes. Can I go to the next? Question number 12. The refracting angle of a prism A is A and refractive index of material of prism is cot A by 2, the angle of minimum deviation. It's a repeating question. You can see this in many question paper. Yes. Alright, Sridhar, no issues. Right. I hope the question is very clear for you. Look at this question, my dear students. The refractive angle of a prism is A. Angle of the prism is A and refractive index of the material of the prism is cot A by 2. The angle of minimum deviation is. Question is direct. Minimum deviation only. So what is the formula? Like we know that refractive index is given. So we can start with the refractive index formula only. What is it? N is equal to refractive index formula. N is equal to sin A plus D by 2 by what? Sin A by 2. This is the basic formula for finding refractive index of the material of the prism. Yeah. So we can substitute here. N is given as cot A by 2. Cot A by 2. As it is I am writing. Cot A by 2 is equal to sin RHS I am writing as it is. A plus D by 2 by sin A by 2. Sin A by 2. Okay. What is this cot? You can see here it is sin. So we need to change the cot. Cot is cos by sin. So we can write it as cos A by 2 by sin A by 2 is equal to sin A plus D by 2 by sin A by 2. This sin A by 2 will be cancelled. So we get cos A by 2 is equal to sin A plus D by 2. Okay, now we need to change, we need to make it similar. So for that we can change cos. Cos theta is sin 90 minus theta. So we get sin 90 minus A by 2 is equal to sin A plus D by 2. Okay, so here we get sin 182, if you can take LCM, so we get is equal to what? Sin A plus D by 2. Now the things is very easy. Tell me your answers, please. That means by equating we get 180 minus A by 2 is equal to A plus D by 2. 2 will be cancelled, so 180 minus A is equal to A plus D. They are asking what is the value of D. So that A will also come this side. The answer will be 180 minus 2A. 180 minus 2A will be the answer, isn't it? How you people are getting A? Some are getting A. Please not this. G and Sanj. It is D, right? Yeah, it is D. It is not A. 180 minus 2A. Those who made the mistake, please check where did you make the mistake and correct it. Yeah, yes, no problem, Rida. Learn from the mistake. Okay, before the board exam, we need to be perfect. Okay, yes, Sanch, it's fine. Now it's fine. Miscalculation is fine, but to make sure that you're not going to make a very simple mistake in the board exam. Okay, going to the next question number 13. This is 12, next is 13. In a double slit experiment, the distance between the slits is increased 10 times, whereas the distance from screen is halved. Then what is the fringe width? Again a question based on the width of the fringe. Quickly answer this, please. Distance between the slits is increased 10 times. Remember, distance between the slit is small letter d. Small letter d becomes 10 times. And the capital D becomes half. So again we can write the formula for beta. Beta is equal to what? Lambda d by d. So beta dash lambda, capital D becomes half, so d by 2 by this become 10 times. So what is the result? Lambda d by 20d. So lambda d by d is beta. So we got the answer. It is comment please. Very good. Satvik, Ibrahim. Yeah, it's option C. Option C becomes 1 by 20. Becomes 1 by 20. 1 by 20. Very easy question. Okay. Yeah. Hisham, correct answer. Going to the next question, number 14. In Young's double slit experiment, the intensity of central maximum is I0. If one slit is closed, the intensity at the same site is. Be careful. Easy question, but be careful, students. The intensity of central maximum is I0. In double slit experiment, the intensity of central maximum is I0. Means if you are closing one of the slit, what will be that answer? Yes, Karthik, right answer. Very good. Comment please. What is the logic of this question? Let me quickly explain it. See, if these are the two slits, this is slit 1, this is slit 2, and here is a screen, you know that at the center point the intensity will be maximum. In our derivation, in our formula, we have taken the intensity of light from this one and this one as I0. As I0 only we have taken the incident one, and we got the resultant intensity as what? 4I0. But in this question I cannot do like that because resultant intensity is given as I0. So what I am doing here is I am just taking this as I and this as I. So if these two are I, you know the resultant intensity is what? 4I. 4I. Because in our derivation and formula, what we have taken is, we have taken this as I0, this as I0, the resultant intensity was 4I0. What is intensity formula? 4I0 cos square 5 by 2, but at the center point, the intensity is maximum and it is 4I0. So here we are taking I and I, so the resultant intensity is what? 4I. That 4I is given as what? I0. So the resultant intensity is I0. I0. It is given. Now what they are asking in this question, if one of the slit is closed, so one of the slit is closed means there is no light coming from this slit. Only one light will reach there. What is its intensity? I. So I is the answer. I. But we need an answer in terms of I0. So here you can see 4I is what? I0. Then what will be I? I0 by 4. I equal to I0 by 4. I0 by 4 is the answer, which is option C. Option C. If there is any confusion, you can ask me. Very good. Sanj, Rida, Atul. Yeah. Everybody got the right answer. Very good. Clear now? Yes. So we are going to the next question now. Question number 15. Simple and direct, but don't make mistake. In a wave, the path difference corresponding to a phase difference phi is. Phase difference is given. What is the corresponding path difference? Quickly comment your answers. You know the relation between path difference and phase difference of a wave. Yes, I can see from G. Yeah. Others also, Ruben, Karthik, Atul. Yeah, simple, right? See, phase difference, if phase difference is 2 pi, you know that the corresponding path difference is what? Lambda. Then if phase difference is 1, it will be lambda by 2 pi. Then if phase difference is phi, it will be lambda by 2 pi into what? Phi. Lambda by 2 pi into phi, that's the right answer, option C. All of you got the correct answer. Keep going, my dear students. I'm going to the next, question number 16. In YDSE, the intensity of light at a point on the screen where the path difference is lambda is I. The intensity of light at a point where the path difference lambda by 3 becomes. A repeating question. We have discussed the same type of question in class also, in our regular classes. Those who can recall that, it's good. Don't make any wide guess. We can do it easily. Look, please understand the question. In Young's double slit experiment, in the intensity of light at a point on the screen where the path difference is lambda. If path difference is lambda, what is the intensity? I. Then if path difference is lambda by 3, what is the intensity? What is the formula we are going to use? I, resultant intensity I is equal to what? 4 I naught cos square 5 by 2. Cos square 5 by 2. Okay. So here, if initially what is the path difference? Lambda. So if path difference is equal to lambda, what is corresponding phase difference? You know that it is 2 pi. Then phi is equal to 2 pi. Then what will be the resultant intensity? I is equal to 4 I naught. I am taking it as I1 because in the first case 4 I naught cos square 2 pi by 2. So this 2 cancelled. Cos square pi, cos 180 minus 1, squaring we get 1. So the answer for that will be 4 I naught. This 4 I naught is given as what? I. This is the first equation I am taking. This is the first equation. Okay, when path difference is lambda, the intensity is 4 I naught. Now what they are asking, if path difference is lambda by 3, if path difference is lambda, we got intensity as 4 I naught. Then in the same formula, we can substitute the value of phi corresponding to lambda by 3. So let's check that one. Listen. If path difference is equal to lambda by 3, then what is the phase difference? Lambda means corresponding phase difference is 2 pi. So 2 pi by 3. 2 pi by 3, please note that 2 pi is 360. 360 by 3 is 120 degrees. So if you have any confusion, you can keep it in degree itself. 120 degrees 5. Now we can substitute, we can find what is the resultant intensity. Therefore I is equal to, or I2 is equal to, same formula I am using, 4 I naught cos square 5 by 2. But what is phi? 120 by 2. That is 60. So we get 4 I naught cos square 60. What is cos 60? 1 by 2 squaring, we get what? 1 by 4. So this 4 got cancelled. So what is I2 value? I2 is equal to I naught. I2 is equal to I naught. But you can see in options everything is in terms of I. So we need this I naught in terms of I. For that you can check our first equation. 4 I naught is what? 4 I naught is I. Then what is I naught? Then I naught is equal to I by 4. So what is the answer for I2? I2 is equal to I by 4. Intensity becomes 1 by 4 times. 1 by 4 times, it's option A. Option A is the right answer. Yes, all of you commented correctly. Very good. Yes. Clear now? Important question. The same question they can ask for 2 marks, 3 marks, MCQs. So all possibilities are there. Alright. Going to the next question now. Question number 17. Two coherent monochromatic light beams of intensities I and 4I are superposed. I and 4I are superposed. The maximum and minimum possible intensities in the resultant beam are. Again an important question. A probable MCQ. Relation between maximum and minimum. Quickly answer this question, my dear students. Please. So, given intensities are I and 4I. That means we can write I1 is equal to 4I. I2 is equal to I. Then if this is the case, what is the formula for the resultant, intensity ratio of I max to I minimum? I max by I minimum is equal to, what is the formula? Root of I1 plus root I2 divided by root I1 minus root I2 the whole square. So just substitute and tell me the answers. Yes, G and Rita, one of them are saying it's option A. Others also quickly. Root I1 plus root I2. You are familiar with this question, I think. Yeah, Karthik, correct. So we can quickly, I1, what is I1? 4I. 4I will be, we get 2I, 2 plus. The other one is 1. Yeah. So other is 2 minus 1. The whole square. Simple, right? 3 square 9. 1 square is 1. 9 is to 1 is the answer. 9I and I. 9I and I. Yes. Very good. Option A is the right answer, my students. Okay, option A is the right answer for this question. So let's go to the next question now. Question number 18. Again, in Young's experiment, the distance between the slits is 0.28 millimeter. The distance between slit and screen is 1.4. The distance between the central bright and third bright is 0.9 centimeter. What is the wavelength of light used? Wavelength of light used. This is also an important question. Distance between central bright and third bright fringe. You know which formula we have to use. If these are the two slits, S1, S2, you know this is the midpoint of the screen. That point I am taking as O. Any other point on the screen we can take it as P. The distance between O and P, if you are taking it as X, we have a direct formula for X. What is that formula? X is equal to capital D by small d into the path difference. So using this formula you can easily solve this kind of question. D by d into path difference. So X is equal to D by d path difference. How do we substitute for that? It is given that the distance between the central bright is here, and the third bright. So third bright, condition for bright, what is the condition for getting bright fringe in interference? It is path difference is n lambda. So here it is given 3 lambda. So I mean third bright means 3 lambda. What is the wavelength? So we got the formula. We got the formula, my dear students. X is equal to D by D into 3 lambda. We have to find what is the value of lambda. Yes. No, Adul. It is square root we have to take, no? Please check. Okay. So lambda is equal to, we get X into D by 3D. So now you can substitute and tell me the answer quickly. X, what is X? Distance between it is 0.9 centimeters. 0.9 into 10 to the power minus 2. Small letter D, distance between the slits 0.28 millimeter, 10 to the power minus 3 by 3 into distance between 1.4. Can you tell me the answer, please? Yeah. Ridha, G, it's B. Very simple, because 9 and 3 are there, 2, 8 and 1.4. This will be 2 and this will be 3. So 3 into 2, 6 only, right? So it will be 6,000 Armstrong will be the answer. Without calculation also we can find the answer here by simply checking the numbers. 6,000 Armstrong. You know what is 1 Armstrong is how many meter? 1 Armstrong is 10 to the power minus 10 meter. Okay, 10 to the power minus 10 meter. Yes, Sanj, Karthik, everybody got the right answer. Very good. So please don't make mistake in these kind of questions. Please, this is the point. Here path difference is there. If it is a dark fringe in a question, if it is given that it's a dark fringe, then what we have to write here? 2n minus 1 into lambda by 2. Path difference is 2n minus 1 into lambda by 2. Bright means it is n lambda. Okay, yes, going to the next question, number 19. A clear transparent glass sphere mu is equal to 1.5 of radius r is immersed in a liquid of refractive index 1.25. A parallel beam of light incident on it will converge to a point. The distance of this point from the center will be. Distance of this point from the center will be. Students, this is not a simple question. We need to use it's a bit complicated. I'll be explaining, so listen carefully. Why it is complicated means they did not give any idea about where is the image formed. It's just like a parallel beam of light is incident on it, it will converge to a point. That's the only data given. It is converged to a point. Distance of this point from the center will be. Okay, so let me show the situation first. What is it actually? A clear transparent glass sphere. So let it be the sphere. This is a sphere. Its refractive index is given of radius r. Radius is immersed in a liquid of refractive index 1.25. So it is in a liquid now. So I'm just taking this as a liquid. Okay, and the refractive index of liquid is also given, it is 1.2. A parallel beam of light incident on it will converge to a point. Incident rays are parallel, so I'm just showing those incident rays as well. This is one ray, this is the other ray. So two rays are there, you can see both of them are parallel, and these rays are converging to a point. Here the confusing part is, if such rays are coming, it will be, how many refraction will be there? There are two surfaces. This is the first surface. From that surface there will be a refraction. From the second surface also there will be a refraction. So converging to a point means that point is the final point, final image formed at a particular point. Okay, but that final image will be formed after double refraction from this. So what we can do here is, let us consider the first part only. After refraction from the first part, assume the image is formed somewhere around here. Okay, just assume. I am not considering the refraction at the second surface, I am just considering the refraction at the first surface only. So after the refraction from the first surface, assume the image is formed here. Okay, right. Now what we need to do is take the first surface only, that means from here to here. For this surface, apply the formula for refraction at a spherical surface. No need to think like such a question, will it come for MCQ? They can, but it's like it's a 3-mark question also. They can ask it for 3-mark also. So listen carefully. This is the first surface. So for that surface, if you are applying refraction at a spherical surface formula, tell me what is the formula for refraction at a spherical surface? It is N2 by V minus N1 by U is equal to N2 minus N1 by R. Let's apply this formula for the first surface. Remember N2, what is N2? It is the refractive index of the second medium. You can see the rays are coming from here. So first medium is liquid, second one is what? The glass. So N2 means refractive index of the glass, that is 1.5. So I am writing it as 1.5 by V. V value we don't know. I am just taking it as V, 1.5 by V minus N1. N1 is refractive index of the liquid, that is given as 1.25. 1.25 by U. What is U? Object distance. Can anybody tell me what is the object distance here? What is the object distance here? Please comment. Object distance. They did not given it directly, but we can get it. Comment please. What is the object distance? Yes, Ruben, right. Yes. Object distance, SG. Correct answer. Incident rays are parallel means, students please note that rays are parallel means you have to assume that the object is at infinity. So object distance is infinity here. You can put it as infinity is equal to N2 minus N1. What is N2? Refractive index of 1.5 again. 1.5 minus N1 1.25. 1.25 divided by R. Radius of curvature is given as R. So you know that 1 by infinity will be 0. So that term will be 0. We get 1.5 by V. 1.5 by V minus 0 equal to 1.5 minus 1.25 is 0.25 divided by R. So by solving this we can take V here, 1.5 R divided by 0.25, we get 6R. 6R. It is not the answer, my dear students. 6R is the image distance for the refraction at the first surface. Is that clear or not? Is that part clear? Please comment. This 6R part is okay or not? Then only I can go to the next step. Please comment. I am waiting for your comments. Is it okay? Yes. So we got 6R. 6R means distance from the surface to this point is 6R, my dear students. And what is the radius of this sphere given? It is R. That means this distance is R, this is also R, and the distance from Here to here we got as 6r. So out of that 6r, 2r is here. This distance is 2r. So surely the remaining distance will be what? 4r. So we can take that distance as what? 4r. Our discussion is not over. I'm just writing this distance is equal to what? 4r. 4r. Okay? Yes. That distance is equal to 4r. Now, remember, we need the distance to the final image. So final image will be formed after the refraction from the second surface. Now the question is, in Lensmaker's formula derivation also we use the same concept. The image formed by the first surface will act as an object for the second surface. So here you can see an intermediate object is there, like image is formed at what distance? 4r distance. That image only will act as an object for the second surface. By using that means, what is the object distance in that case? It is 4r. Object distance is 4r, and that is for this surface. So we need to use the same formula for the second surface as well, but be careful. If you are taking the second surface, my dear students, which is N2. N2 is, now you can see that the ray is traveling from glass to water. So N2 is refractive index of liquid, that is 1.25. So I'm writing the formula 1.25 N2 by V. V we don't know, again I'm writing V. We are going to find the final distance. Okay, V. N2 by V minus N1. What is N1? N1 is refractive index of glass, because the light is going from glass to water, that is 1.5 by U. U, what is U value? I told you, like, this image only act as an object. That means this distance will be acting as what? Object. That distance, object distance is 4r. 1.5 divided by 4r is equal to N2 minus N1. So we get 1.25 minus 1.5, that is minus 0.25. Minus 0.25 divided by, minus 0.25 divided by r. R means what? R means the radius of the second surface. Problem is, it is also r, but you know that its sign is negative, it's on the other side. That means here we get what? Minus r. That minus and minus will be cancelled. So I'm just keeping 1.25 by V on this side. The other side I get 0.25 by r. This will go to the other side. It will become plus 1.5 divided by 4r. Okay. So we get this one as, this is 0.25 means 1 by 4, right? So we get 1 by 4r plus 1.5 by 4r. That is 2.5 by 4r. 2.5 by 4r is equal to what? 1.25 by V. So solving, we get V is equal to, V only we have to find, 1.25 into 4r divided by 2.5. So 2r, we get V as what? 2r. V is 2r. Is it the answer? Again, no, this is not the answer. This is the image distance. Image distance from where? That means we are talking about the image formed by this surface. So from this surface the final image is formed at a distance of 2r. That means, my dear students, we can see that the final image is formed at this point. Okay, what is the question they are asking? The distance of this point from the center. So from here it is 2r, then from the center how much will be that distance? Now you can come into your answer. Please, what is our final answer? What is our final answer? We need the distance from here to here. I hope it is clear. It's a bit lengthy, a lot of ideas we are using. Come into your answers. What is the right answer? This distance is 2r, this is r. So the final answer will be 2r plus r. Yes, Ruben, right answer. 2r plus r will be what? 3r. 3r. Yes, 3r is the right answer for this question. Okay, yes, clear now? Please note this. I am going to the next question. You can, if any confusion is there, you can watch it later. Okay, so the time is also going to be finished. Last question for today. Question number 20. A light source placed at the bottom of a water beaker 9 cm deep forms an illuminated circle of radius 11 cm at its surface. If the depth of the water in the beaker is increased to 18 cm, the radius of the illuminated circle will be. So these type of question, not exactly the same type, but based on the same concept, we have discussed many questions. Let's check what is happening here. A light source places at the bottom of water beaker 9 centimeter. So let us take a beaker. Okay, it's a beaker, and in this beaker there is some water. Okay, right. Place at the bottom of a water beaker 9 cm deep. So assume it is kept at 9 cm. 9 cm is here. Let us take this. This is a source. Illuminated circle of radius 11 cm on its surface. That means if illuminated circle of radius means light will be going like this, light will be going like this. This is a circle. Its radius is given as what? 11 centimeter. Why there is a limit for the light to go make a circle? Because you know that the maximum angle up to which the light can go here is what? Till the critical angle. After that it cannot go. If angle of incidence goes beyond the critical angle, the ray will be undergoing TIR, it will come back. So maximum angle up to which it can go is what? Till the critical angle. Okay, so this radius is given as how much? 11 centimeter. Now initially what is the depth? This depth is 9. And when you are making 18, what will be the radius? So before solving this question, let's try to make a general idea. For that, what I am doing here is, I am just taking the radius as r and this height as what? H. Okay. So this is a critical angle C. If this angle is C, this angle will also be what? C. Okay. So by looking this triangle, you can see tan C is equal to what? Tan C is equal to R by H. R by H. What is C? C is a critical angle. For a given liquid or for a given object, a transparent object, critical angle is a constant, yes or no? That means tan C is always a constant. When H changes, R will also change, but tan C is a constant. That means R1 by H1 is equal to what? R2 by H2. This is the logic for this question. So they are asking R2 value. So we can write R2 is equal to, tell me. R2 is equal to R1 by H1 into H2. Okay. Now we can easily substitute. What is R1? R1 is 11 centimeter. What is H1? 9 centimeter. What is H2? 18 centimeter. 18 by 9. So what is the answer? It is 22 centimeter. Very simple question. 22 centimeter. Yeah. Option C is the right answer. 22 centimeter. Okay. So now the time is 7:45. We are going to wind up today's session. I hope you really enjoyed this. And the optics part is not over, because you know it is a lengthy chapter. So we'll be having one more session for optics. You'll be getting the link of that. It is not tomorrow. I think it will be on your first exam. 22nd is your English exam. After that, on the same day, you'll be having chemistry and physics session. On that day, I'll be coming with remaining questions from the optics. Until then, bye bye. See you in the next class. Thank you very much, my dear students. Keep going.